So I'm joined by Professor Albert Helberg from Northwest University. And now, Albert and us, we've known each other for a long, long time, in fact. And Albert, I've always associated you with incredibly high-tech endeavors. And I think that what I want to talk about briefly today is another incredibly high-tech endeavor. But to me, this one talks very much about a future and a spectacular future. And this is all about using solar energy to power vehicles. And in this case, a vehicle for a race.
That's right, yeah, thank you. We've been building solar cars now for about 4 years, so we're very late in this field. I mean, the international solar teams have been building solar cars for almost 30 years now. But
they haven't got it right. You guys are going to get it right.
Yeah. Some teams get it right very well, but we're doing quite well for South African teams. We recently participated in the World Solar Challenge 2015. And we were the first team ever from Africa to cross that finish line. And you must remember the way that they rank you there is, did you finish the race? And then which position did you attain? And then thereafter, how far did you actually manage to compete in the race? So we actually finished the race, and it's only about a third to two-thirds of the field that actually finished the race.
In fact, let's pause there for a moment, because when you're talking about high technology, new developments, there's a fair amount of risk. I mean, how do you get this car to really get to the end? Because that is clearly, actually, that's first prize.
Yes, no, most definitely. Reliability is the first thing that you need to build on. And the challenge is so high-tech. You can't just take a car off the road and take the engine out, put an electric motor in, a couple of lead-acid batteries, a solar panel on the top, and then expect to actually compete in this type of event.
Right.
You're taking all the inefficiencies that you had with the old petrol-driven car concept and translating that over into the electric field, and you can't do that. Power-to-weight ratio, for example, the electric motors that we're using use about as much power as a large kettle element,
Yes.
which is about between 2.5 to 3 kilowatts, and that's at peak powers. So we're talking that we on average use less than you would use with a hairdryer. So a hairdryer itself uses about 1,200 to 1,500 watts, and that we gather from the sun, store it in a battery, and then put it on the road as efficiently as possible. And we're talking 90% plus efficiency.
That is absolutely incredible. One of the things that came out of this little conversation now was, you're not just talking about electric machines and photovoltaics, you're talking about a real system.
Yes.
And a multiplicity of engineering disciplines in it. I would imagine that from the student's point of view, this is an absolutely phenomenal learning environment.
Most definitely. The type of environments that we're talking about, we have engineering students from mechanical engineering, and 1 or 2 from chemical, electrical, electronic, control systems, telecommunications. We have a telemetry system in the car.
Yes.
It's got cruise control. Do you believe that?
Very good, very good.
Everything is built by the students.
I think that's
It's a
magnificent.
student competition. We guide them, and then they start getting momentum. And at one stage, they just run away with you. You just have to hang on and see where are they going and try and put this whole system together. Because it's suspension, it's wheels, it's running resistance, it's aerodynamics, it's materials, it's chemistry, it's electrical control systems, it's telemetry. It's all in there, and it must work together seamlessly.
That's right. And it's the optimization of the entire system that makes the vehicle a winning vehicle, isn't
Yes,
it?
most definitely.
And then in terms of what's happening next in South Africa,
Right.
you guys are getting this thing ready for another race, aren't you?
That's right. Well, in actual fact, our car is running at the moment. It's going to compete in the 2016 Sasol Solar Challenge. That takes place from the 24th of September. Yes, 24th September. It's in a couple of weeks' time. And it runs all the way from Pretoria to Cape Town over 8 days, finishing in Cape Town on the 1st of October.
Rapidly through the winelands.
Must be. We're not going to stop there. We'll stop in Cape Town.
Fantastic. Well, I wish you guys all the very, very best. I've been watching the success of this car with some interest. I think it's absolutely brilliant. And I think kudos, first African car across the line. I think that's absolutely phenomenal. So we're going to hold thumbs for you now on the trip down to the coast. All the very best. And I mean, I wish the students well, because there's no doubt these youngsters are going to come out of this project as superb engineers, without question.
Thank you very much. Yeah, our sponsors are, of course, very happy with this because they're going to get these students.
Yes.
So TIA sees a lot of entrepreneurs there, Motla,
Yes.
the people from the mines that support us as well.
Brilliant.
They know that energy is a major problem. and they need entrepreneurs that are going to take this field and just run in the industry.
Wouldn't it be amazing if these youngsters carry that through and develop their career around this initiative?
They're doing it already.
Fantastic. All the very best.
Thank you.
Thanks.